Hey guys, welcome to the next session in my iOS tutorial. In this session, we are going to learn about auto layout. So, as the name denotes, auto layout is nothing but instructing the iOS to lay out your application controls. Let's say you have a button, you have a text field. So, to instruct the OS to lay out these elements within your user interface at the respective position wherever you want, and that has to be automatically laid out according to the device in which the user is using your application. So that is the main aim of this one. So because like in iOS we have iPhone, we have iPad. In iPhone itself we have different size of devices, right? So you just can't go ahead and tell that you just need a button with the size of 40 cross 40, something like that, because it might look good in a smaller device, but when you run your application in a bigger size devices, that button will look so small, right? So these are all the elements we will be covering, or we will try to understand how things works in iOS. Okay, so before we jump into the topic, I hope you might have noticed that I told here 40 point, right? Because why I mentioned that unit in points, because typically we used to measure dimensions in pixels, right? But in iOS we will be using points, right? So the reason is, in iOS we have devices with different resolutions, right? This might have like 640 cross 968 pixels, and other things has a lot of different resolutions, right? So you just can't go ahead and set dimensions according to the pixels, because it's varying from device to device. And also with the major difference is, we have devices with different scale factors. Let's say you have a normal screen density, and you have a retina screen density, and also you have a super retina screen density, right? Because what are all these things means actually? Everyone says it's a retina display, it's a 4K, like that, right? So in iOS, it means if the device is normal, then like when someone says your phone is 1280 cross 1920 pixels, then it means that this is width, this is height, and in your device, in the horizontal, like this is your width, right? And this is your height. So in this axis, you can assume like you are having 1280 boxes. So each box is 1 pixel. So that is the reason why we are saying like 1280 pixel, and this is for normal density devices. Okay. But when we talk about retina is nothing but, I told here each box is 1 pixel, right? In retina, it's nothing but each box contains 2 pixels. Like the manufacturer manufactures the display, and each visible box will be containing 2 pixels, so that they can accommodate a lot of pixels in like in our case 2 pixels, so that your display clarity becomes higher. So that is why we call it as a retina. And you might have figured it out the same way when we call about super retina. Each box will be containing 3 pixels. So, we call this normal as 1x scale factor, and this retina is 2x scale factor, and then this 3 super retina is 3x scale factor. Okay. So now coming to the point, I was telling we have different scale factor device. Let's say we might have 1x devices, we may have 2x devices, we may have 3x devices, which means this device, in one box 1 pixel, in one box 2 pixel, in one box 3 pixels, right? So just to be clear on that. Okay, so now we know about what is a scale factor. and what is pixels, right? Now, since we have different scale factors and then different sized devices, we need a generic measuring unit so that you can use them to set the size for the elements in your user interface, and that is where points comes. We can shortly call it as PT or points. Okay, so when I say 1 point, it means if the device is normal, retina, super retina. If it is 1 point, then it means that it will have 1 pixel, and it will have the retina will have 2 pixel, and then super retina will have 3 pixel. Okay, so that is why, like, we need the point unit. So when you set a button with of size 40 point as width, then it means that in 1 pixel device it will consume 40 pixel. Into 2x devices it will take 80 pixel. In 3x device it will take 120 pixels. Okay, cool. So now we know what is scale factor, what is pixels, and what is points. Great. So the next thing is size classes. So since we have iPhones in different orientations, like let's say an iPhone can be in portrait, or sometimes it can be in landscape orientation, or the iPad can be in portrait or landscape orientation. So in order to support the layout controls for all these orientations, we need to have certain conditions, right? So in order to support all these things, in order to provide the constraints respectively, we need to have some ways to figure out in what orientation the device or the application is running. So to detect that, we have below situations. So let's say we have compact, regular, compact, regular, width, width, height, height. So the combinations are compact, compact, and then compact, regular, and then regular, compact, and then regular, regular, which means width is compact, height is compact, and width is compact, height is regular. Width is regular, height is compact, and then this one is both width and height are regular, right? So these are all the use cases. So let's say now what you can do is you can supply a constraint for a button. Let's say okay, so before we jump into that, we need to understand what is this compact regular, the that thing is, right? So let's say when we say compact with compact height, our iPhone 4 is the 4-inch device, which is very small, right? So this falls under compact width and then compact height. Fine. And even if you turn it, then it will be coming like the same stuff, compact width and then compact height in the landscape orientation also. But if you go for, let's say you take iPhone 6 or 11 or any other iPhone devices, if it is a portrait orientation, then the device will be like this, right? And here the width is, this one is width, and then this one is height. Now the width is small, so compact, whereas height is a normal one, so we call it as regular, right? So this falls under compact width and then regular height size classes. And if you turn the iPhone to the landscape orientation, then your width becomes this one, and then your height becomes this one, whereas your height, sorry, width is regular one, whereas the height is compact one. So this is what. So in this situation, if you want to supply 40 point as a button height, let's say this is my button for compact width and then regular height, then that will be applied for the portrait mode. Whereas if you supply 80 point for regular width and then compact height, then that will be considered for the landscape orientation of the iPhone. Okay, right. The same applies for all other iPhones. When it comes to iPad, so your iPad will be something like this, and your both the width and then height are almost regular sizes, like it's large, right? So be it portrait or be it landscape mode, your iPad will always be in regular size class. Okay, so if you want to supply a constraint only for iPad, then you need to set that constraint with this size class. Now you know what is size class, right? So next, constraints. What is constraints? Like you are giving constraints for an element to be laid out, right? So in order to instruct the OS to properly lay out a control in the device screen space, a control need four things to properly lay it out. Let's say you have a button and you want to lay out this button in your screen. Okay, so four things you needed. One, how much, what is the width of that button? You know what, like when you have a button, the system should know how big it has to draw the button, right? So in that case, how, what is the width? And then second, what is the height? Fine. Now the system knows how big the button has to be drawn. But the thing is, where I should start drawing this button in the x axis, right? So x position. And then from the y axis, where I should start drawing this button. In our case, this is the y axis and then this is the x axis, right? So Y position. So what I'm trying to say is, whenever you set a constraint for an element, you need to always make sure these four things are satisfied for the control. Then only the system will be able to know where it has to start and how big it has to be drawn. Okay. Fine. So this is how the these are all the things you should be knowing in order to start learning the auto layout. Okay, but again, what I'm saying is this: you won't get master in this in the day one itself. This is not something like a formula, like you apply it, you get it. No, nothing like that. The more you practice laying out different controls according to different screen sizes, you will understand it more better. So this theory apart, we will see how to apply all these concepts in a practical application in my next session. Thank you for watching this video. See you soon.